Hi everyone, my name is Xiangqian Li, a PhD student of Shandong University, China. I'm thrilled to have the opportunity to deliver a presentation. I will present our work of the paper titled Personalized User Interface Elements Recommendation System. Graphical User Interface (GUI) is widely used in various systems, from mobile applications to self-service equipment in specific scenarios, as well as mixed reality, virtual reality, and other interactive environments, which is an important medium for users to interact with the system. Graphic User Interface Element is a basic component of GUI. Usually, interface designers modify graphic user interface elements, such as buttons, search boxes, according to the application theme, and obtain user evaluation by A/B tests or user surveys before publishing. Considering the diversity of users, the effect achieved by this method often has several limitations, including increasing the learning cost of user operations and making users spend more time in the adaptation of the interface. Is it possible to recommend GUIs that better match users' preferences at the time they open the interface? In existing studies, some attempts have been made to design different interfaces by users' characteristics, such as age or personality test results, but such approaches are not flexible in terms of solution adaptation and require designers to carefully design multiple solutions. One type of data-driven approach is to use machine learning to fit the collected data to obtain a design solution. Current work of this kind focuses more on generic GUI or GUIE recommendations and requires a lot of data support, which is not conducive to wide portability and applications. Based on this, we propose personalized user interface elements recommendation system. In this figure, the recommendation system consists of database, saving user information, design element solutions, and user evaluations of design element solutions, and the model. In the training phase, the recommendation system fits a personalized recommendation model by user characteristics and user evaluation of the solution. In the test, when a new user arrives, it is only necessary to obtain basic interface by bounding to the account to the model to recommend a solution based on user characteristics and render it to the GUI front end. This framework uses a data-driven approach to personalized recommendations, and one of the core issues is the selection of the models. When choosing the model, we need to consider two main problems: how to handle the sparsity of evaluation data due to combinatorial explosion, how to exploit the association between user and GUI features. To alleviate problems of sparsity and feature intersection, the factorization machine (FM) is proposed to decompose sparse matrices and add feature intersection. But each feature has only one latent vector, and the strength of intersection between different features is uncontrollable. To a lesser extent, there is likely to be a strong correlation between user characteristics and design element solution characteristics and within design element solution characteristics. Therefore, here we adopt the field-aware factorization machine (FFM) model that can describe the feature intersection in more detail. To evaluate the effectiveness of the system and the corresponding model, we conducted experiments. The experimental data is collected through the WeChat applet, including two parts: user personal information and ratings of user interface elements. The tested need to fill in personal information and then complete the evaluation of the two user interface elements of the Find or Reset button and the search box. In terms of user evaluation, we adopted a 5-point Likert scale. 161 user evaluations on the button and the search bar solutions are collected. A total of 120 button styles and a total of 60 search box styles. A user will be assigned 30% of all styles randomly during evaluations. Additionally, because the proportion of ethnic groups other than Han in the collected data is too small, so that is not included. The final user features include gender, age, residence, and major. Here is the distribution of user features. In order to further study the relationship between user characteristics and user preference for design elements, we calculated the mutual information between all features vector pairs in the data and user evaluation. We found that some intersections of user features and GUI features or within GUI features highly affects user evaluations. In our work, we used these three evaluation metrics. We experimented with LR, SVR, JBDT, FM, and FFM models, each of which fit two datasets with and without user features. The results show that some widely used machine learning models tend to bring performance degradation when combining user information, while FM-based models are able to exploit the association between features more effectively. This is the result of Coulson similarity is shown. The solution recommended by FFM and JBDT using user features has a higher similarity with the user preference solution. In conclusion, we propose personalized user interface elements recommendation system based on user information. We found that users' evaluation of UI elements is related to the user's own characteristics, but also to the intersection of the characteristics of the user interface element solution itself. For the future works, we will carry out the following aspects. Knowledge between the user and the GUI features need to be better analyzed. The combination of GUIs on the overall interface need to be studied. The trade-off between user preference and efficiency need to be studied. That's all about my presentation today. Thank you for your listening.